Alright, 8th graders, today we're talking about solving quadratic equations by graphing, and whether or not we can use a graph to solve a quadratic equation. So let's first say what a quadratic equation is. So it's nonlinear. More specifically, it's a parabola. And it's written in the form ax squared plus bx plus c. So we're going to go ahead and move right along into the actual problems. So to solve by graphing on this first one, you have a couple of options. So first of all, we know that our y-intercept is at -4 because our c value is always our y-intercept. We know that our graph opens up. We don't necessarily know that -4 is or isn't the vertex. So we can make an xy chart, and I would pick things like 1 and -1 for x values, 2 and -2, just to see where those points land. So if I use 1, 1 squared is 1, 1 minus 4 is -3. -1 is going to do the same thing. -1 squared is 1, 1 minus 4 is -3. So 1, -3, -1, -3. And then 2 squared is 4, 4 minus 4 is 0. -2 squared is 4, 4 minus 4 is 0. So 2, 0, -2, 0. That -4 was our vertex. So our parabola looks like this. Now, when we're solving these equations, we are looking for what does x equal as it crosses the x-axis. So I'm looking for, these are called the zeros because they're when y equals 0. So the zeros are at x equals 2 and -2 would be my solutions. Now, we have factored already, so we can look at this equation that's given and we can factor it. We can say that's a perfect square, that's a perfect square, and there's a minus sign in the middle, so I know that my equation is x minus 2, x plus 2 equals 0. And so x equals 2 and -2. Again, these are the zeros, so this is where our lines cross the x-axis. Alright, let's look at the next one. On this one, again, we can see our c value is 0, so our parabola definitely passes through the point 0, 0. And then we can make an xy chart to graph it. So I would pick 1, -1, and see from there what to pick next. So if we pick 1, 1 squared is 1, plus 3 times 1 is 3, so that's 4. If I pick -1, -1 squared is 1, 3 times -1 is -3, so that gives me -2. So I have 1, 4, -1, -2. So I want to keep going I think, to my left. So I might pick -2, -3, and see where this goes, maybe even -4. So -2 squared is 4, plus 3 times -2 is -6, which gives me -2, -2. Okay, so since I see this happening, then I'll know that my axis of symmetry is in the middle of 1 and 2 at 1.5. So my parabola is going to keep going now up at the same rate. So because I was over 1 up 2, I'm going to be over 1 up 2, and at -3 I should be back at 0. Let's check it. -3 times -3 is 9. 3 times -3 is -9, so that does equal 0. And then at -4, I should be up here at 4. So 4 squared is 16. 16 plus 3 times -4 is -12. And I am back at 4. So parabola is symmetrical. And looks like this. So now, again, I'm always looking for where does my parabola cross the x-axis, and it crosses at 0 and at -3. So that's my final answer. I'm just looking for the zeros. Where does my parabola cross? I guess I didn't really need to get these 2 points because this is all I'm really interested in. And then I could have figured this out also by looking at factoring these. So I can divide x out of both of those, and we would get x plus 3 equals 0. So now either this has to equal 0 or this has to equal 0, so that when we multiply we get 0. So now x equals 0, and then x plus 3, so what plus 3 would equal 0, and that's -3 plus 3 would equal 0. So we get the same answer whether we graph it or we factor it. So we're just looking for the zeros. Where does my parabola cross the x-axis? Alright, looking at this next set of problems, C and D, we are going to try these. -x squared plus 2x equals 0. So I know that my C value is at 0, so I can put that point on, and then I can make my XY chart, and I would pick -1 and +1 so that I can see what's going on. So if I pick -1, -1 squared would be -1 plus 2 times -1, so that's -3. So there's that point. If I fill in 1, I get -1 squared, which is -1 plus 2, which is 1. So again, I'm not sure. This looks like it's increasing. So I would try 2 and 3 to see if those work. -2 squared is -4. Notice this squared is only on the x value, so when I'm doing this, that negative has to stay out in front. The squared is just on the plain old 2, so that negative carries through. And then plus 2 times 2 is 4, so I get 0. And so here we can see that it's coming back down, and it's going to match up with this side. So my solutions here are 0 and 2. My zeros are x equals 0, x equals 2. And again, could I have figured that out by factoring? I could have. I would have divided out an x and been left with negative x plus 2. So x would be 0, and then negative what plus 2 equals 0, 2. So that's my answer. On the next one, I can see that my c value is a positive 1. So that's my y-intercept. I'm going to make an x and y chart. And I would do 1 and 2 and see where those go. Negative 1. So 1 squared is 1, minus 2, plus 1 gives me 0. And then 2 squared is 4, minus 4 plus 1 is 1. So it looks like here's my vertex already. Now, this one only crosses at 1, or only touches the x-axis at 1. So my solution is just x equals 1. Let's see if we get that same thing when we factor. So I'm looking for what multiplies to make 1 and what adds to make negative 2. So that'd be x minus 1, x minus 1. And so that makes sense. They're both x equals 1, and we would only have to write that one time. Alright, on the rest of the problems in this notes section, I want you to go ahead and try them. This next set is the same as the others. You just add 16 to both sides before you start solving, and then same thing over here, add 25 before you start solving. You can use your XY charts. You can, factoring is fine with me. These bigger numbers start to get ickier and ickier, so they become more and more difficult. However you want to solve them is fine, as long as you're getting correct answers. I'm fine with it. So try those two, and then the 3 on the following page, and see what you get. We'll go over these tomorrow. Have a great night.